Hi, let us understand different type of NoSQL databases. NoSQL database can be broadly categorized into four different type of databases: key value database, columnar database, document database, and graph database. Let us see in detail about these databases. First, let us start with key value database, which is much easier to understand. Let us start with key value database. A good example for key value database is Redis or React database. They all work with a similar concept where every record will be a key and a value. Let us see with an example. Assume I'll be having a record and it can have a key. Key can be of any complex object. In this case, let us consider that as a session ID. And it will have an object or the value. Again, it is going to be another complex object. So this could be the entire session as such that is getting stored for that particular session ID. Very good example is whenever a user is playing a game, the user will have an option to store the entire state as it is and later they can recover. The entire object of that particular game with all the information so that it can be recovered will be stored as a value, and the corresponding session ID or the game name will be stored as an ID. Like this, we will be having n number of records. So each record will have a key ID and a value. The key will be unique for that specific record. And as we discussed earlier, every NoSQL databases, they work in a distributed fashion. In the sense, they will be having n number of workers and a master that's going to manage the workers. The next type of database that we are going to discuss is document database, where the record will be stored as a JSON document. Let us see an example for a JSON document. This is a good example for JSON document. When I say JSON document, JavaScript object notation, and this will be used to represent any complex document or any complex record. In this case, I have first name, last name, employee ID, designation. Along with that, I have language expertise, again which is an array of data. And within that, I have another complex object called car that's going to maintain n number of records. Like this, I can maintain any type of hierarchy, and the hierarchy doesn't need to be following a standard. I can have any depth of hierarchy, and this way of representing the data would help me to store any relation of data. Let us have an understanding. Assume I am going to store a profile information. Whenever I am storing a profile, I might add n number of address. And along with the profile, I might store educational or qualification information. I might have a number of educational details as well. When these records get stored in a normal RDBMS, what would happen? I will end up having three different tables. I'll have a personal table, and I'll have address table, and I'll have educational table. And all these records would get stored within the RDBMS, and the relation would be maintained. So the address would get stored within the address table, and educational information will get stored within the education table, and there will be a 1:n relationship between the personal and education information. Whenever I want to display this particular information back to the user, I may have to do a join between these data. Whenever I am going to do a join, it has to merge the data between these tables and bring the data back into the UI and display that to the user. When that's about to happen, and if I am going to have the data in a distributed fashion, that's where the distributed constraint comes into picture. RDBMS is not going to exist in a distributed fashion, so join would work much easier way. But if I am going to have the data distributed across different systems, let us assume the data is distributed across different systems. Say the education is stored in another database, physically distributed system. The join has to happen through the network, and that's going to be very, very ineffective. To display the record, it has to do the join across the network. That's why the need for document database came into picture. The entire document of this particular user, here I will be having 3 educational details and 3 address details, all together will be stored as a single document. When it is getting stored in the distributed fashion, the entire record will be available in a single worker machine. So within the entire record, the JSON record will be stored in any of the worker machine, and the master will be coordinating. So I'll be having the JSON files. Each JSON file will be a record and it would get distributed. And the master will be coordinating what record is available in what system. A very good example for document-based database is MongoDB. And another example is CouchDB. There are n number of document-based database. If you look at the document-based database, that would fit into the location where it is satisfying the partition tolerance. Many of the NoSQL databases, they would be fitting into this specific location. That is either into this specific area or in this specific area. When it is satisfying the consistency and partition tolerance, I'll be getting a specific type of databases. When it is satisfying availability and partition tolerance, I'll be getting a different type of databases. Based on what is more required, either consistency or availability, based on that, I'll be choosing the database for that specific business need. So in a summary, key value based database, it's going to store every record as key and values. And document based database, every record will be stored as a JSON document and that would get distributed across different systems. And we have seen about two different type of databases, that is key value store database and document database in this specific lecture.